In this video, I'm going to go over solving rational inequalities. The first step to solving a rational inequality is to write it as an equality. So I'm going to replace the equal sign, well, the greater than symbol with an equal sign. Next, what I want you to do is I want to find the undefined values of the fraction. That means I'm going to set my bottom. So I took x minus 3, setting it equal to 0. This tells me that x cannot be in the solution set when it's equal to 3. So x cannot be 3. So now I'm going to go ahead and solve. So step 1, write as an equal sign. Step 2, find the undefined values. And step 3 is going to be solve. I'm going to put that over 1, and I'm going to solve by making the bottom of that 1 x minus 3. So I'm going to have to multiply the top and the bottom by x minus 3. Now you can also cross multiply, but some people think this is easier because this is very similar to the rational equations that we did. So 0 times this will just be 0 over x minus 3. These bottoms are now the same, so they cross off. And you end up getting x plus 7 equals 0, subtract the 7, and we know that x equals negative 7. I'm going to go ahead in step, this is 1, 2, 3, so this is step 4, and make a number line. On my number line, I need to put two values. I need to put the undefined value, which was 3, and the value that I solved for, which was negative 7. Now 3 is undefined, and every time you put an undefined value on the number line, it will always be an open circle. And negative 7 is going to depend on the inequality symbol, and that is not equal to, there's no bar underneath, so it will be open. And the last thing I need to do for the number line is figure out where I'm going to shade. Now you can use your calculator by putting the original into y equals and seeing the graph and seeing where to shade, but I'm going to do it by hand because I don't have a calculator on here. And the easiest number to test is 0. So I'm going to plug in 0, and I get 7 over negative 3 is greater than 0. That is not true because 7 over negative 3 comes out negative, and a negative number is never greater than 0. So I'm going to go ahead and shade on the outsides of my number line. My last step is to state my answer. Because these are not connected, it is an OR case. And I'm going to say x is less than negative 7 because it's over here, and or x is greater than 3 because it's over there. To get full credit, you need the number line and the statement. Okay, next one. Same thing. I'm going to rewrite this as an equality. I'm going to go to the side and set the bottom equal to 0 and find out what value of x makes this undefined. So x can't be 2. I'm going to do this one a little bit differently by putting 5 over 1 and cross multiplying, which is completely valid. So negative x plus 8 times 1 equals 5 times x minus 2. This 1 goes in, we get the same exact thing, and I get 5x minus 10. I'm going to go ahead and solve by adding x over and adding 10. I end up getting 18 equals 6x. Dividing by 6, I end up getting x equals 3. So now I have my two values that go on my number line. I'm going to go ahead and make my number line. So my number line is going to have the two values of 3 and 2. The 2 will be open because that's the undefined value. We can't be 2. And 3 is going to be closed, and that's because if you look at the original symbol of the problem, it is equal to. And I'm going to go ahead and test 0. 0 is over here. So I'm going to plug in 0 into my original and see if it makes the left side greater than 5. So it'll be negative 0 plus 8, and 0 minus 2 is greater than 5. That'll be 8 over negative 2 is greater than or equal to 5. That's negative 4 is greater than or equal to 5. That is not true. So I'm not going to shade where 0 is. 0 is over here. I'm going to shade in between. This is an AND case, meaning that x is in the middle, 2 is over here, and 3 is over here. You always use less than, and this one's going to be equal to because it's closed. Alright, with the next one, again, I'm going to rewrite it as an equality. And on the side, I'm going to figure out what x values I can't be. Well, x can't be 2 for the first fraction, and x can't be negative 4 for the second one, because those values would make these undefined. I'm going to go ahead and cross multiply. I end up getting 1 times 2 minus x equals 3 times x plus 4. This should be an x. So distributing this in, I get 2 minus x equals, distributing that in, I get 3x plus 12. Solving, I add x, and I get 2 equals 4x plus 12. If I subtract 12, I end up getting negative 10 equals 4x. I'm going to now divide by 4, and I get x equals negative 10 over 4. Reducing that, that's negative 5 over 2, meaning we have negative 2.5 if you really want to see it as a fraction. So this number line will have 3 values of x. Well, 3 values on my number line. I'm going to have 2, negative 4, and negative 2.5. So 2 is going to be over here with an open circle because it makes it undefined. Negative 4 is going to be over here with another open circle because it makes it undefined. Negative 2.5 will be in the middle somewhere with an open circle because if I look at, actually it's closed. Because if you look at here, I solved for x, which was 2.5, and that's an equal to, so that one's closed. Okay, so now I'm going to test 0. 0 is right here. So if I plug in 0, I get 2 minus 0 is less than or equal to 1 over 0 plus 4. That's 3 over 2 is less than or equal to 1 over 4. Well, 3 over 2 is 1.5, and 1 over 4 is 0.25, and that's not true. So I'm not going to shade where 0 is, I'm going to shade on every other area. So here, not where 0 is, but here. Now this is an and an or case. My first statement is going to be negative 4 is less than x, which is less than or equal to negative 2.5, or x is greater than 2. And that's my final answer.